And programming a function is a piece of code that you give a name and potentially has inputs and outputs. In JavaScript in particular, there are a few parts that go into defining a function. The first part is a name. When you give a function a name, like in this case add, that's the name you can reuse in other places in your code when you want to use this functionality again. The next part to define the function is parameter names. These are the inputs to the function that you can use as local variables within the function. Unlike a language like a Java or a C, you don't have to declare the type of the parameter in the function. Another part to defining a function in JavaScript is the functionality, or what actually happens in the function. Everything put between the curly braces is the functionality of the function. The last part to defining a function in JavaScript is an optional one, that being a return statement. A return statement can be used in one of two ways. You can put nothing after the return statement and use it to literally return from this function. A different thing you can do with it is use it to return a value. Return a value will make that value available to the location the function was originally called at, meaning when you call this add function, the sum of the two numbers being added will be available in the location that you originally called the add function. In JavaScript, a function expression is a way of defining a function within an expression using the function keyword that can be used to make nameless functions. And an expression is a unit of code that results in a value. In listening to that long, winding definition, you're probably wondering, why do I care about that if I can still just define a regular function? Well, I'm glad you probably asked that question. Let me cook up an example where it might come in handy. Let's say you have this string s that equals hi. What you want to do is just capitalize the first letter of hi. JavaScript doesn't have a pre-baked function to do this. Let's say you only need to do this one time throughout your code, so that makes it so you don't need to define a regular function. A function expression works like this. You store it in a variable like const cap first equals the function keyword and then any arguments you want to take in this case, word. First, you're going to extract the first letter of the word. So let first letter equals word.char at 0. Then you're going to get the rest of the word, so you're going to slice it from 1 onwards. Then you're going to call toUpperCase on the first letter to uppercase it. Finally, at the end of the function, you're going to return the result of concatenating the newly capitalized first letter with the rest of the string. But you could do all of that without a function expression, right? What's the point? The big point here is readability. If you go and read back over this code, you can read the function expression where you store the function in a variable called cap first, and then know all the rest of that function is working to capitalize the first letter of the word passed in. Other than incredibly good comments, you would have no indication of the intent of this code if you did the same thing but outside of a function expression. In JavaScript, an arrow function is a way of defining a function within an expression that can be used to create nameless functions and has another feature that differentiates them from regular function expressions. The arrow in this case can be read like this function does. Also, without curly braces, the expression after the arrow is assumed to be returned, meaning in full this line reads, inside the variable const, store the arrow function that takes in 2 arguments and returns them being added together. Here, if an arrow function only takes in a single argument, it doesn't have to be surrounded in parentheses. Also, if you're just console logging out a message, you don't want to return anything, so that's why the console log is surrounded in curly braces. If an arrow function takes in no arguments, though, you must use an empty set of parentheses. For functions that take in other functions, you can use arrow functions for more concise code. Here, you're passing in an arrow function to filter that returns true if a given element is positive, which is why you end up with the arrow just containing the element 2, because that's the only even element. I would tell you 7 ways to Sunday, though, that this is taking arrow functions too far. Having to focus to grasp intent should never be the case. As small a step as naming the arrow function is even can go a long way to be explicit about intent and properly communicating what your code is doing. There's nothing out of the ordinary with this piece of code. You're using a regular function expression as a constructor to make a person object. If you turn that very same function expression constructor into an arrow function constructor, though, it breaks. It turns out that if you use function expressions as constructors, then they get their own this that allows them to refer to the object that the constructor is creating. When you turn it into an arrow function, though, you lose this privilege and you keep the this of the surrounding scope, in this case the global scope, which doesn't allow you to create any objects. In JavaScript, the spread operator allows you to expand stuff like arrays or strings. In the context of functions, it can expand things into multiple arguments to a function. In here, even though the array has 3 elements, the first 2 are passed to sum as arguments when the spread operator is used on the array. That's why sum returns 3, as the first 2 elements are 1 and 2. Here, Same with the string, even though it has 3 characters, the first 2 characters are passed to sum as arguments when the spread operator is used on the string. That's why sum returns 1, 2, as the 1 and the 2 are concatenated together. A closure in JavaScript is the enclosure of a function's functionality, as well as all of the variables and functions it has access to from where it was defined. This here is the simplest possible example of a closure. The closure contains the functionality to return the string A and the definition of the function itself. This, however, is uninteresting and not very useful. To start to get interesting, we have to introduce the term lexical scoping. With regards to functions in JavaScript, lexical scoping means that functions are executed using the variable scope that was in effect when it was defined, not the variable scope in effect when it was called. This is the simplest possible example to explain what that definition just meant. When you call the function A has access to the scope from when it was defined, meaning it has access to the capital A variable and is able to be printed out in the function. And if you try printing out capital A right after the call to A, you'll see it even further. You get a reference error because capital A is only defined within the function. This example is where everything comes together. Let's go through it line by line. This function paycheck sets a money variable equal to 0. It has an inner function payday that increments your money by $10 and then returns the new amount of money. Outside the inner function in the outer function ends by returning the inner function. The first thing this achieves is you can't give yourself a small loan of $1 million. If you try to do money plus equals $1 million, you'll get a reference error because money isn't defined in the global scope. Going further, let's define a const salary variable that equals calling the function paycheck. This effectively gives you access to the key topic of this video, a closure. Salary holds both the inner function payday as well as the variables and function that payday has access to in the surrounding scope. So if you're calling salary, you're calling payday, which has access to money, sees that it's 0, and then increments it by 10. If you call salary again, you're calling payday, which has access to money, sees that it's 10, and then increments it by 10 again. The last little wrinkle of this will be defining the second salary variable. Defining the second salary variable really illustrates the power of closures. A second salary variable gives you access to the payday function again and the surrounding scope. Why that's so big is salary 2 now has an entirely new reference to money, meaning it starts at 0 and is entirely separate from whatever you do to salary's copy of money. Like other objects in JavaScript, functions have a toString method. For built-in methods, you get a weird output. Here on console.log, you get function log, parentheses, curly braces, square brackets, native code. What does that mean? This is an oversimplification, but there are many different versions of JavaScript. All versions of JavaScript expect the built-in functions to work the same way, but they may, and almost certainly are, implemented with different code. So toString returning that native code bit is always true, and it doesn't have to worry about the version of JavaScript any given person is using. If you make your own function, though, toString is league simpler. Say you have a function add that takes in 2 parameters, A and B, and then you just return the sum of A and B. Calling toString on the add function you just made will give you back a string containing the code you just wrote out. Like and subscribe to learn more.